In this episode of Finno-Greek machining we are having fun with nuts. These are the cylinder attaching nuts for this Stirshurst engine. So, nuts it will be. So, we are doing 8 couples of this type of nuts. This is the side view of one of these. And then we are making an a jig for the milling machine in order to cut the flats for the nut. What is the diameter if we think that I'm going to use an 8mm wrench for this nut? That's my plan anyway. So I needed to know what is the minimum diameter for this type of nut. So here is some calculations, and first of all, when we are talking about the circle, if you take a radius of a circle, you also find the radius all over the place like this. If you take the radius, you can divide the circumference of a circle with that radius quite easily. Yeah, you can try it out, it goes quite nicely. So, what this means, that if we have the wrench, W, wrench, as in wrench, if this is the wrench diameter, right here. So, this means that this same wrench appears here as well, as one part of this triangle here. It is half of that wrench. And then we also have fourth of the diameter, meaning half of the radius in this edge. So, what is the radius? Okay. So, now we have this nice book, and there is a presentation in one page, like that. And it means that if we have some angle here, so we can calculate the length of this one when we know the angle and when we know the length of that one. Okay, and on 30 degrees it is there, I believe. So, okay, I took that figure, that number here, and then I put it here. So it means that the diameter divided by 4 is equal to the wrench width divided by 2 multiplied this figure which I got from this book. You can check the arithmetics here. Okay, then when we multiply everything here by 4, so we get that the dimension is 2 times width times the same figure. So it means that the dimension is width times double that figure. Okay, so now if we want to have a wrench of 8mm, so the minimum diameter for this should be 9.23mm. Okay, so 10mm bar is good enough. Okay, well, but this is something you can, this is actually a constant. This here, you can use inches or feet or light years, and it works every time. Okay, so first of all we have to go to the lathe and do something there. Well, this is today's menu for the lathe. First we put 10mm stock into the chuck and dial it in. And when that is done, I will face it with this one. And when that is done, when the facing is done, then we will put the center there. And after we have that center, we will drill a 4mm hole deep enough. after that we will chamfer it slightly. And when that is done, we part it off to the correct length. This is repeated 8 times, and then we have one different piece. Now that we have done all these parts, so next step will be to machine them in the drill press. So first I will chamfer each and everything. I didn't do this in the lathe because I noticed that it slows down the process quite a bit, change every time this, so I decided to just do this in the drill press where I will be doing the threading as well. So first I will chamfer them, and when that is done, when the chamfering is done, then I will set up my Tapmatic and thread each and every of them to M5. Now I'm setting up this Tapmatic. First of all, this is very handy when you have to do similar threads multiple times, and well, let me show you what this is actually. So typically when you thread, you are using a tap wrench and so on. But you can also do this with in a drill press. And well, it happens in a way that you first have a thing like Tapmatic. Well, when you push it down, it will do the thread, and when you pull it up, you know, this has movement like this. When you pull it up, it reverses the direction and threads out the tap from the threads. As simple as that. Okay. There are adjustments here. This ring here, you can rotate it, that ring, and this one is to adjust the torque of this thing. And of course with M5 it should be quite light. This is to avoid breaking your tap. Well, I'm using a spiral flute tap here in this case. Okay. So, first of all, second of all, third of all, this is an American invention. It means that it has, for example, these hex screws are American standard. So this is 1/8 of an inch. And European guys, if you own these things, please don't try any metric wrenches here. They will not work very well. Okay. So there is actually a vise inside here. When I put this tap there, there will be a vise which tightens it to the end of the tap. So, and then we have this collet. There are 2 collets for this one, for smaller taps, which is this one, and for the larger taps, which is in my box there on. So, well, you have it's a collet actually, and there is you put your collet on like that. Choose the correct where is the correct place? Choose the correct tightening thing there, and then you just tighten it a little bit so that namely this doesn't it only holds it in the center. So then there is a hole which you can look through, so you can see when your tap is in the correct position, and then when you find the correct side, you screw in this like that. Now it is there. I believe it is there. Is it? Yeah. So now This one, this vise inside there prevents this tap from rotating freely. This collet system doesn't prevent it from rotating, it's for other purposes. It's for keeping it somewhat in place. And you don't need to torque this very heavily. Now, okay, now it is there. It is there, and I believe I have adjusted the torque quite well. So next step is to put this into the drill press. Okay, here I'm in the drill press, and now we need to set this up. As you can see, it doesn't quite fit into there. At the moment I need to lower the table somewhat. And this is just lowering it suitably. Well, this is easy when you go down. I believe we are quite near the correct place now, hopefully. Let's see. I don't want to put it too low. Well, yeah. I didn't remember that this one has the ability to turn like that. Now I just need to take care that I don't drop. Oh. There you are. I believe it's quite in the correct place. Okay. There you are. And now let's tighten this so it doesn't rotate by itself. And now we, what is needed here for this particular thing? This is taking the torque when you are reversing it. And this one is, well, I have a tube which goes into here. Just like that. There you are. Now, because when you pull it up, it will torque to there. Hopefully it doesn't drop. It shouldn't, but yeah. Okay, now I will try to center this thing. Let's put our first candidate there. Well, I need my magnifying glasses now. Well, this has quite a lot of flex. That's intentional actually. It's not broken or anything, it just has quite a lot of flex. It's, the design is such that... Okay. I think we are there. Oh yeah, and then the speed for the tapping. We need that one. Let's see. Well, okay, let's try that one. That looks like fast, but actually this is, you will see it's not that fast at all. Okay, a moment of truth. Let me show you nearer. Now, moment of truth. There you are. Threads done for that one. Now you understand why this is so practical. And it's totally true. Next, please. And this is really nice. It works like a dream, actually, this one, when you set it up correctly. You can set this up incorrectly as well. And then you just go there. There you are. This is practical when you have multiple pieces, but the setup time, the overhead of setting this up is so much work that for a single thread it doesn't it's not practical. But for 9, yes. What was that? Ah, my part is actually rolling there. Okay. But it doesn't break the tap, and that's really nice. You can actually save quite a lot of money with this one if you think about this. You don't break so many taps, and your taps last longer, especially if you are making a lot of holes. Oh yeah. It might be that my torque is a little bit too heavy on this one. I probably need to adjust it a little bit down. Let's see what happens now. Yeah, it's okay. Well, there you are. Again. It wants to rotate in my vice. This is funny. Well, not so funny, but it will. Wants to do that. I don't know, this vice is crap. Really crap. And this one I don't want to make the threads all the way through, because not because of I couldn't, but I want the bolt I screw in there to stop somewhere. Okay, and now I need to check which side, because the other one is filed and the other one is machined, and this one is machined. I need to be very, because this is now a mandrel for our rest of the job in the milling machine. Yeah. Done. All 9 of them. Welcome to my nut factory. So this is a dividing head, and I have dialed in this piece inside here. It's the mandrel for the nuts, and the End mill is located in such a way that it is 4 mm from that plane and 1 mm under the side. So when I now put another nut here, like this, and these need to be tightened quite well. I'm using my vice grip and I take it so there you are. It doesn't matter if it marks the face. So we start at 0. That's our 0. I'm using direct indexing, so I have disconnected the worm and I have removed all the discs, etc. from this dividing head. So I'm just moving it manually. And now, let's see, first cut. And yes, I was a little bit suspicious whether this will rotate it itself, but it doesn't if you tighten it well. It could benefit from some cutting oil, not a lot, so like that. Let's put it down there, so yeah. That was the first cut. Now we turn it 60 degrees. Like that. And, I'm turning it backwards in order to eliminate the burr from a previous cut. Next, and the last one. Now we can use an ordinary wrench to remove it from there. there is a lot of burr, so therefore I need to, okay, yeah. Huh. And yes, there is your nut. And now a few more. So, here are the nuts. Finished in the milling machine, and yeah, they look good, but they have a lot of burr in them. Every corner has a burr, and now the next step will be go to my lathe, put this mandrel there, center it, and then for every nut do first I will do it like this side, and then I will do a small chamfer with the file, not with the lathe, with the file is enough. And then I try to chamfer these corners with the file while it's running. Well, it has to be a very gentle process. Let's see how that goes. And after that is finished, I will turn it around like this and do this corner here. Well, that was my nut factory. Here is the result of this nut factory. Oh yeah, and well, let's see how these will fit into the machine. They should look really good. So in the next episode we will be doing well, cylinder heads. That will be our task next time. Till then, bye!